So we have earlier on found the solutions to these problems. We are looking at part B. So the failure of a machine in service is computer monitored by the growth sign signal curve display. When the signal curve grows to its critical point, the machine trips off itself. If the signal function is represented by this f of theta equal to theta minus sine theta divided by theta minus tan theta, verify the applicability of Hospitali's rule on f theta, hence determine the value at which the machine trips off. So here we are going to use the Hospitali's rule to find the limit of this function as theta tends to 0. Because as theta tends to 0, that's where we have the critical point um, where the machine is going to trip. So we need to find the condition for this machine to trip. That will be the value of f of theta as theta tends to 0. So we have f of theta, which is equal to theta minus sine theta divided by theta minus tan theta. So what we do, we want to apply the Hospitali's rule, which is applied when we find that if we limit theta, limit theta, limit this function, the limit of the function as theta tends to 0 for theta minus sine theta divided by theta minus tan theta. This becomes, when I put in 0 here, becomes 0 minus 0 divided by 0 minus 0, which becomes the indeterminate form. So the indeterminate form leads us to using Hospitali's rule. So what does that mean? We need to find d by the theta of the numerator, which is theta minus sine theta, and this gives us 1 minus cos theta. Let us also find d by the theta of theta minus tan theta, which is the denominator. This gives us 1 minus sec squared theta. This is where people get problems. If you don't know how to differentiate a tan theta very fast, then you'll have to suffer to go back and look at it in the first principles. So we are going to now limit the function as theta tends to 0 of theta minus sine theta out of theta minus tan theta is the same as if we took the limit of the derivative, the same as limit as theta tends to 0 of 1 minus cos theta divided by 1 minus sec squared theta. When I substituting a 0, I will have 1 minus 0, I mean minus 1. So I will have 1 minus 1 divided by 1 minus 1 again. And this is not good. So we have to, this is giving us another indeterminate form. So we apply Hospitali's rule again. Apply Hospitali's rule again until the indeterminate form vanishes. So we are going to look at d, the theta of 1 minus cos theta. So this becomes, this is sine theta. Okay? This is sine theta. So we also look for d, the theta of 1 minus sec squared theta. So when I differentiate this 1 minus sec squared theta, I'll get 2 tan theta sec squared theta. If you don't know how to do this, then you go and look at, of course, if we differentiate 1, you get a 0. But now differentiating 1 out of cos squared theta. Here you use quotient rule So you'll be having v times du, which becomes 0, minus u, which is 1, times dv. So if I differentiate this cos squared theta, I will have a 2, then cos theta, sin theta, then everything divided by cos power 4 theta. So what does that give you? This would give you, remember what you have here is negative 2 sin theta cos theta divided by cos squared theta times cos squared theta. So this square goes away with that, and finally you would have negative 2 sin theta out of cos theta. Okay, then finally you will be remaining with times 1 out of cos squared theta. So this becomes negative 2 tan theta sec squared theta. But you remember, when you differentiated this, there was negative 1, so that's why this negative will multiply with that negative and it will go. Uh, so d theta of 1 minus sec squared theta therefore would be 2 tan theta sec squared theta. So that was side work. Now we proceed. If I now take limit, so I want to take limit as theta tends to 0 of sine theta divided by 2 tan theta sec squared theta. This also gives you 0 out of 0. You again go ahead and differentiate. So you differentiate d of the theta of sine theta, you get, so we are applying Hopital's rule again. Hopital's rule again. That's what we are doing. So this becomes cos theta. When I differentiate this d by the theta of 2 tan theta sec squared theta, I get, when you try it, you'll find that you'll have 2 sec to power 4 theta, okay, plus 4 sec squared theta tan squared theta. So when you don't know how to differentiate, here you become stuck. But here, you're going to be using the product rule. So maybe you have this as u, then the other one as v. And you look at v du d theta plus u dv d theta, whereby you take a tan, you differentiate it, then you multiply by you multiply by sec squared, then you add. So finally, you'll find yourself with this. So now let's take the limit of the function as theta tends to 0 of 1 minus sine theta divided by 1 minus, this was theta, so tan theta will be the same as limiting now the other derivative as theta tends to 0 of cos of theta divided by 2 sec power 4 of theta plus 2 4 tan squared theta, then sec squared theta. So when I put in 0 here, this gives me 1 out of, this becomes also 1, so 2 into 1, then plus 0. So this becomes 2. So that means the machine will trip when f of theta equals a half. That is as theta tends to 0. So that's how you can conclude. Once you find the limit of that function, then you will have finished. Because that's all they wanted you to, they wanted to test if you know how to find the limit of that function, okay, by applying